I would like to introduce Rick Bohan. Rick is the Portland Cement Association's Vice President of Sustainability, where he is responsible for the development and delivery of PCA's roadmap to carbon neutrality. Prior to his current role, he served as Senior Director of Research and Technology. Rick has more than 30 years of experience in the cement and concrete industries, including positions in materials engineering, geotechnical consulting, and failure investigations. He is co-editor and chapter author of PCA's Innovations in Portland Cement Manufacturing and a licensed professional engineer. Rick joins us today from Las Vegas, Nevada. Please welcome Rick Bohan.
Hey, thank you so much, Bill. So the roadmap to carbon neutrality. PCA represents the cement producers in the United States, and it is our commitment to reach carbon neutrality by the year 2050. Now, to do that, we are looking at the entire value chain, and although this is a linear format, it actually circles back on itself. So I'm going to be addressing each portion within this value chain, starting with the clinker, moving to cement, then to concrete construction, and finally we'll talk about concrete being used as a CO2 sink. Now, how are we going to get to carbon neutrality? Well, there's two methods. One is to directly reduce the amount of CO2 through the processes and products that we put out, and another is to avoid the CO2. I like to use the weight control analogy. So from a weight control basis, if you want to lose weight, well, you can look at portion size. Analogously, that's what direct CO2 reductions are. They are actual physical reductions in the amount of CO2, or for weight control, the amount, the size of the plate. Now, avoided CO2 is a little bit different. And again, using the weight control analogy, it doesn't matter if you have a very small portion size if all you're eating are bacon triple cheeseburgers. That may sound crazy, but let's face it, that's not going to help you too much. So avoided CO2 is essentially what is on that plate. Now, to do that, what we'll find and what we have seen is that most of what we can do is actually doable today. There are reasons why it's not being done. In some cases, regulatory disincentives. In others, it's simply a question of folks haven't just been able to adopt these technologies as quickly as they would like. I want to talk about optimization, though. A lot of what we can do is simply an optimization exercise. And what that means is twofold. I think we're all familiar with the bell curve, so we can do two things: shifting the curve and tightening or shaping the curve. By shifting the curve, if you think about it, you have people that are on the far right-hand side of the curve. They're the star performers. People on the far left, they're lagging behind. Shifting the curve simply means that the people lagging behind, or the products, or the materials, now become the average. The average, because they're being shifted, now become the excellent or the star performers. And the star performers continue to always do good, and they're always pushing the envelope. Shaping the curve means that rather than having a flat curve, we actually have a very tight curve. So the difference between the star performers, the star materials, the star producers, and the less star performers, the less star producers, the less star materials, the difference is actually much, much smaller. So we start with our value chain with a product, an intermediate product called clinker, which, by the way, unless you go to a cement plant, you will never see clinker. It is an intermediate product, but it is a critical product in manufacturing cement. Now, cement, when it's manufactured, roughly more than 60% of the CO2 that's emitted is emitted because of the chemical process. If we don't emit the CO2, we don't make cement. It's just that simple. To make that cement, to make that chemical process requires tremendous heat, and that requires combustion. So slightly less than 40% of our CO2 emissions come from combustion. What can we do to reduce those CO2, the CO2 footprint there? Firstly, we can look at other materials that don't have to go through that processing. Those include what we call decarbonated or pre-calcined raw materials. Materials from other industries like the steel and slag industry, the fly ash industry. Second thing we can do is increase our efficiency. Cement manufacturing is one of the most thermodynamically efficient processes. But by optimizing and shifting the curve, we can get even more efficient tomorrow than we are today. The third thing we can do is looking at the CO2 coming from combustion. We can look at using different fuels that have less CO2 emissions, a lot of alternative fuels. And by the way, that also includes things like switching ultimately to hydrogen and other transformative fuels. And then looking at carbon capture, use, and sequestration. We think there's a huge role for this. And as we get closer down the road in our roadmap, we know that CCUS will be a big part of that plan. So that was the first link in the value chain. The second link, though, is optimizing cement. Now, a lot of people see a lot of different statistics. I can tell you the US cement industry contributes about 0.17% on a CO2 basis globally to US greenhouse gas emissions. Obviously, this is the contribution we have. Now, how can we optimize cement? Well, number one, we can use less clinker and use other materials like limestone. Using a product called Portland limestone cement, we can reduce the CO2 footprint of cement by up to 10%. That's a product already out there today. It's readily available, and it's just a question of overcoming institutional inertia. People ask me, well, what's the difference between Portland limestone cement and other cements? And I use the analogy, it's a little bit like the difference between regular Coke and Coke Zero. Same taste, same caffeine amount, but different formulation. We're also can optimize cement by looking at new cements. And keep in mind, we've got to ship our product all sorts of places. So we can get to carbon neutrality by looking at zero emission transportation. We've been working with the rail carriers who are already envisioning switching diesel locomotives into electric locomotives. Likewise, shipping our product by truck. We all know that there's now a move afoot to shift that truck fleet into zero emission vehicles. So that was optimizing clinker, cement. Now we get to concrete. Cement, when it's mixed with sand, water, slag, fly ash, silica fume, limestone, all sorts of other materials, becomes concrete. You walk on a concrete sidewalk, you live in a concrete apartment building, you land on a concrete runway. We can optimize concrete by using increasing amounts of what we call supplementary cementitious materials. I've mentioned a few of those. We can optimize concrete also by reducing the amount of energy that it takes to actually mix and transport this material. And again, looking at things like zero emission vehicles. And of course, also cutting down on the energy required to manufacture and mix this material up. And then finally, there's a variety of breakthrough technologies that material scientists are working on even today. So our product, though, is not clinker or cement, or for that matter, concrete. Our product is a built environment. And this is really a key linchpoint or linchpin to our roadmap to carbon neutrality. How do you optimize construction? There are 4 phases in construction: design, construction, use, and end of life. And there are things we can do within each phase. I want to emphasize everything I've mentioned, including the material on this slide, these are things we can do today with the right regulatory framework and the right incentives to do so. So in the design phase, things like 3D modeling, building information modeling, virtual reality design. In the construction phase, looking at zero waste construction sites, which has become the norm in Europe, but has not happened here in the US. On the use side, you've probably heard about environmental product declarations and life cycle cost analysis. So rather than look at a product's carbon footprint from cradle to gate, look at it from cradle all the way to grave. And actually with concrete, there is no grave because all that material, even when it's demolished, can be reused. And at the end of life, again, I'll cover this a little bit later, is recognizing that concrete can be used as a carbon sink. And by the way, we're not the only ones that recognize the benefits of optimizing construction. The US General Services Administration has what they call a high performance building program. there are substantial benefits that accrue when you take this type of approach. So if you look, for example, on the right-hand side, if you compare to legacy stock buildings, high performance buildings include 23% less energy use, 28% less water use, a decrease in 23% of building operating expenses, 9% less waste going to landfills. And of course, here's another thing that most people don't think about. Not only is this a high performance building that really has great benefits for society, it has great benefits for tenant satisfaction. Real basic things to do. I've listed a half dozen things. So again, even the federal government in the United States recognizes that optimizing construction really is the key to our future. And then finally, concrete as a carbon sink. Most people don't realize this, but it is a technical fact, a scientific fact that we've known about for almost 100 years. Concrete absorbs CO2. It is one of the few inorganic materials that can do so. And the fact is, once concrete structures are put in place, as long as they are exposed to the air, they will start to absorb CO2 and continue to absorb CO2 throughout its lifetime. So, key point that most people aren't aware of, about 10% of the CO2 generated from the manufacture, the transportation, and the use of cement and concrete is actually absorbed throughout the life of a concrete structure. And in fact, because we're looking at a circular economy, concrete as a material can be recycled and not only used as aggregate for new concrete, but in many cases can be used as feed material back at the cement plant. So essentially turning this material, turning the cement and concrete value chain into a circular economy. So at each step of the way, our value chain includes what we can do to get to carbon neutrality. A couple of key points. No one link in this chain will get us to carbon neutrality. Each one of them is required. However, all of them can get us to carbon neutrality by 2050. Second key point, we cannot do this alone. The US cement industry is endorsing finalizing our roadmap on June 29th. At that point, we'll be reaching out to everybody and anyone who touches any part of this value chain. Now that includes a lot of people like rail carriers, truck manufacturers, cement plant providers, refractory equipment providers. It also includes contractors, consultants, designers, anyone who works with cement and concrete. It includes policymakers. We're reaching out because we need their help to get to carbon neutrality by 2050. I'm often asked, well, can we get there sooner? Yes, we can, with the right incentives, with the right support. And that includes everybody. I'm dating myself, but I can remember when recycling wasn't a big deal until people started to realize, hey, this is important for our planet. So the entire value chain, starting with clinker at the cement plant, an intermediate product you will not see, followed by cement, the glue that holds everything together when it's mixed with sand, water, and aggregate to form concrete, which is, of course, one of the most useful and innovative building materials known to mankind, which also creates our built environment in the construction link phase. And then finally, recognizing that just because the building is standing doesn't mean that the story ends. That building will continue to absorb CO2 throughout its lifetime. Thank you so much.
I would like to thank our partner, Penware, Senator Mike Cuff, and MLA Richard Gottfried, our speakers, and of course, all of you for attending today. This webinar was recorded and is available on the PNBRC website at buildingresiliencecoalition.org and the PNBRC YouTube channel. We encourage you to share this with your networks and join us again as we continue to explore the benefits of cement, concrete, and the concrete masonry's contribution to sustainability. Thank you for joining us. Good day.